Welcome to a class on electrostatics. In electrostatics, we deal with the properties of electric charges at rest. What is static electricity? The property of rubbed substances due to which they attract light objects is called static electricity. When suitable substances are rubbed together, they acquire equal and opposite charges. For example, when a glass rod is rubbed with a silk cloth, glass rod acquire positive charges and silk cloth acquire equal negative charges. At the same time, when an ebonite rod is rubbed with a fur cloth, ebonite rod acquire negative charges and fur cloth acquire equal positive charges. Rubbing does not create any electric charges. It merely transfers electrons from the atoms of one material to the other. Hence, we call this electricity as static electricity or frictional electricity. Electric charge. It is a scalar quantity and the SI unit is Coulomb. What are the fundamental laws of electrostatics? Number 1. There are two kinds of electric charges, positive and negative. Number 2. Light charges repel each other and unlight charges attract each other. A positive charge and a positive charge will repel. A negative charge and a negative charge will repel, while a positive charge and negative charge will attract. Now we examine the properties of electric charges at rest. Number 1. Additive nature of electric charges. Total charge of a system is the algebraic sum of all individual charges located at different locations in the system. Now we can see the illustration given. A system is given three charges Q1, Q2, Q3. Therefore, the total charge of the system is Q1 plus Q2 plus Q3. Number 2. Quantization of electric charge. Total charge of a body is always an integral multiple of a basic quantum of charge. That is Q equals NE. N can be any integer. E is the basic unit of electric charge, that is the charge carried by an electron. Number 3. Conservation of charge. Total charge in an isolated system remain constant. Charge can neither be created nor be destroyed. They can only be transferred from one body to another. Coulomb's law. The force of attraction or repulsion between two stationary point charges is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. Mathematical statement of Coulomb's law. If 2 point charges Q1 and Q2 are separated by a distance r, then the force F between them is F proportional to Q1 Q2 and F inversely proportional to r squared. F equals K into Q1 Q2 by r squared. K is the constant of proportionality called electrostatic force constant. Again, K equals 1 by 4 pi epsilon, where epsilon is the permittivity of the medium between the two charges. Epsilon equals epsilon 0 into epsilon r. Epsilon 0 is the permittivity of free space or vacuum, and epsilon r is the relative permittivity of the medium, or we call it to be dielectric constant. Therefore, the value of K depends on the medium between the two charges and the unit of measurement. Dielectric constant. As we said earlier, it is the ratio of the force between two charges placed at some distance apart in free space to the force between the same charges when in a given medium same distance apart. That is epsilon r equal epsilon by epsilon 0. Dielectric constant of different media. For vacuum, epsilon r equals 1, and for water, epsilon r equal 80.
For vacuum, epsilon r is equal to 1. Therefore, K is equal to 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9 Newton meter square Coulomb raised to minus 2.
Coulomb's law in vector form. The force exerted on Q2 by charge Q1 F21 equals K into Q1 Q2 by R12 square into unit vector R12. The force exerted on charge Q1 by charge Q2 F12 equals K into Q1 Q2 divided by R21 square into unit vector R21. Unit vector R21 is equal to minus R12. Therefore, F21 equals minus F12. That is, the force exerted by the first charge on second charge is equal and opposite to that exerted by the second charge on first charge. Properties of Coulomb's force. Coulomb's force follow Newton's third law of motion. They act along the line joining the charges. Thus, they are central forces. Now let us look at the differences and similarities between electrostatic and gravitational forces. Similarities. Both forces obey inverse square law, that is F proportional to 1 by R square. Both forces are proportional to the product of masses or charges. Both forces act along the line joining the centers.
Both forces can operate in vacuum.
Now we look at the differences. Gravitational forces are always attractive in nature. Electrostatic forces can be attractive or repulsive. Gravitational forces do not depend on the medium, but electrostatic forces depend on medium between two charges. Electrostatic forces are stronger than gravitational forces.